give you some examples, how to use it, and then we give you some tasks to solve them on your own. So what is SQL? SQL stands for Structured Query Language. It's also called SQL sometimes. Like the most important use case for us probably is just requesting data from a big warehouse. Maybe some of us will at some point in our career have this problem to get some data from our company. Like it's a standardized declarative programming language for relational databases. So like to understand like the difference between a declarative and an imperative language, I have given you like a table that tells you the differences. SQL is a declarative programming language. The difference between different programming languages is that you just give like the condition you're requesting, and then it gives you the result. What we do here a lot with Python is rather we give a step-by-step analysis and then we run through a script. This is also then reflected in the structure. The commands in SQL are rather short and precise, and as you maybe have realized in our second home assignment, like the Python code can become very long. The use case, like I already said, is basically requesting data from a data warehouse, and the use case for imperative languages is much brighter, like we've seen in Java, where there are many different ways you can use it. Also, like a motivation why you should learn or why you should care about SQL. Here we see the two graphs from the developer survey of 2022 from Stack Overflow. SQL is one of the most used languages, and on the right-hand side, we also see why this is the case, why it's used so much, because the most used databases always rely on SQL, or you can at least use SQL to access the data that's stored in this data warehouse.
Okay, so now, we have seen what SQL is, and why should we learn it? So let's take a brief look at the history and how it evolved. In 1970, Edgar Frank Codd, that was an English computer scientist employed at IBM, published a paper called A Relational Model of Data for Language or Large Shared Databases. And this was, so to say, the start of the era of relational databases in computer science. Here, to understand what relational databases are and how they look like and what's maybe the main difference to other non-relational databases, let's go to the next slide. Here you can see at the time Codd published his paper, non-relational databases were dominant, so hierarchical and network databases, for example, you see on the left. In hierarchical databases, the data are stored in a tree structure. So at the top, you can see, very small, to customers, accounts, and transactions. And as I said, they are stored in a tree structure. And the same data you can see on the left bottom. In a network database, you have exactly the same data. Again, customers, accounts, and transactions. But here you can also see the links between the two data sets. So between the top data set and the bottom data set, between the two customers, so to say. And both types of databases are still used nowadays, but they are referred as quite inflexible. In his paper, Codd proposed a quite new idea, modeling data with relations, or also called tables. And this allowed for more flexibility, and you could also add new relations, new tables without modifying existing tables. And this was the way how working with a database became much easier. And on the right, you can see different tables. So one table for customers, accounts, product, and transaction. And you can see the top tables are related to each other by the customer ID. So they both have one column with the same information, which relate both tables to each other. So we have, so to say, redundant data, but yeah, this is also true for the product and the transaction table. So the product table is related to the account table by the product ID, and the same for transaction with the account ID. So now hopefully you have an idea how a relational database looks like, and we can go back to the history. Yeah, in his paper, Cod also proposed a set of operations to extract data from these relational databases. And this was the basis for the system R, which started in 1973. So this was a research project to explore Cod's ideas. And it was led by Don Chamberlain and Ray Boyce. And they developed then SQL, which it was called later, or SQL, during the 1970s. And yeah, even they were very surprised how easy this language turned to be out. So they said, for the first time, we could see how a query that would require a complex program could be reduced to a few simple lines. So as you can see later, SQL is very similar to simple spoken English, so to say. And today, SQL is referred as the standard relational database management system language. And as we've seen, it's one of the top popular technologies nowadays.
Then quickly again, the pros and cons of SQL. Like already mentioned, it's widely used and supported. People have been working on it for more than 50 years now. It's easy to use and easy to learn, and it's highly scalable, and this is what it was basically invented for. So like everything you cannot store in Excel, even though it maybe didn't even exist back then, but so that you can store a lot of data in there. The cons, though, is that this language is also more limited than maybe Python. We can do so much in Python, and this is more for this only for this single use case. And as Celine just shown, it has limited support for non-relational data. It's rather for these Excel spreadsheets like looking data. And it can also not handle unstructured data like videos or text, images. Exactly. So if you got bored of all this theory, then it's now time to wake up. Here's an example how to use SQL. Here we see a table, and we want to get specific information from this table. In reality, this would be much longer and would have much more rows and columns, but we just send this simple code that you can see on the top right. Select means give me information. Star just means all the elements in the whole row, and we specify we want to get the data from the employees table, and the only we could already leave it at this, then we would get the whole table, but we can also specify we just want the elements where we have as city London. So this would be the result.
Okay, so yeah, we have seen this example, and let's take a quick look at the SQL syntax. SQL as a language comprises several types of operations that allows to perform various commands and operations, as I said. And on this slide, you can see 4 parts of SQL that represent in general what the language can be used for. And these are the data definition language, data manipulation language. These are the most important for our presentation, so you can see lots of them in our practical part later. Then data control language, and last but not least, the transaction control language. So the first one, the DDL, is a set of statements that allows to define and modify data structures and objects. And objects are, for example, tables. And typical commands are create, alter, drop, and truncate. And as the name suggests, create is you can use for creating data structures, databases, and objects as tables, for example. With alter, you can change existing objects. So, for example, you can add or rename a column in a table. With drop, you can drop the whole table from the database. And truncate is not, as with truncate, you don't delete the whole table, but you remain the table as a whole, but delete all the content of it. Okay, so once you have created a database and filled it with information, we can go to the data manipulation language. And yeah, it's also very easy. As the name says, it contains statements that allow us to manipulate data in a table of a database. So typical commands are select, insert, update, and delete. So with select, we have seen this. Toby has explained it. You can retrieve data from a table. Insert, yeah, you can insert data in a table, also very easy. Update, you can renew existing data in a table. And delete is quite similar with truncate, but you don't remove all the data in a table, but you can precisely specify which things you want to be removed. The next one is the data control language. It's a set of statements that allow us to manage the rights of users in a database. So basically, it's grant and revoke. So with grant, you give permission to a user, and with revoke, it's the opposite. So you revoke this permission. And yeah, last but not least, the TCL comprises a set of statements that allow us to save and restore changes to a database. So yeah, when working in real life, some changes are not saved automatically, so you have to tell the computer what you wish to happen, and you can do this with a commit. So changes are saved, and once you've committed some changes, you cannot undo them. And rollback is yeah, will let you make a step back, so to say, it reverts you to the last non-committed state. Okay, and
there's just one thing I want to add. So usually the SQL databases are the heart of each organization, so they are very sensitive for the user. So as a junior or even as an intern, you will never use any of the other two parts except then this DML part. So you only have to access to select some databases, or just this which the select statement that you just saw, that you can just select the data, get what you want out of this big data that the organization have, and then you can just import it to an Excel file or a Python file, and you can work with that. So usually you're not going to work with the others, even as a data scientist there in an organization.
Yeah, that's also the reason why this is our focus on the practical part. So of course, yeah. And the last thing for SQL syntax are the language elements. Yeah, first of all, keywords. So they are predefined words in SQL, and if they are reserved, for example, for select, you cannot name a table select. Identifiers are simply names on database objects, so on tables. Clauses, you can see some examples at the top. So every line is, so to say, a clause beginning with a keyword. Expression, you can see one here also. So it can be a string like Hamburg, or it can be also a scalar. So for for example, if where zip code equal to 123, for example. Then predicates, this is a condition which can be evaluated by SQL. So it can be said, okay, it's true or false, for example. Yeah, statement, this is the whole thing you can see. And in significant white spaces, I think that's also important to say that SQL ignores white spaces. So you can put them in for readability, but they don't matter for the code. And yeah, now David will continue with the practical part. And I think before we do that, we have a cheat sheet for you. So maybe you can follow a bit better.
Okay, so for those that do not get the paper yet, I would ask you to please go to this website. So you can just type it over. I think it's large enough, or you can also see it in the Zoom. And I even use like a link shortener, so it's not that long.
Can you put it in the chat?
Copy link. So this link is the first one. This is the second one. So the first one, you can also, let me go back to those that want to just manually copy. So you can find it in the Zoom chat or big in the Zoom video sharing, or you can just copy it from here. So this will redirect you to my cloud storage provider, where I've uploaded a zip, which contains one script that will set up the database that we will use for our practical part, and the other one will be the solutions for those tasks that I will present. But it will not contain the solutions for the task you are about to do later. Yeah. And the second one is the website that I actually use to code. Sorry. Okay, so the second one is the website we'll actually use to code. So there you can just run scripts, and there's like a web application where you can use SQL. So I hope you could all download the zip and the website, and then just follow what I do to set it up. So I'll do it here live. Can we maybe get this laptop out of here? Thanks. Okay, so what you want to do is go to this website. You click on download, download the zip, open it, and then just export it. You can just like do it like this and drag it into the downloads folder. Okay. Now you go to this second website that I've linked, SQL Online. Should look like this, right? Does anyone have problems with getting there, downloading the zip, unpacking it, and coming to this website?
Where can we find the link anymore?
I mean, it's still in Zoom, in the Zoom chat. I mean, if you joined late, then maybe you don't have the chat history, or you can just type it from here.
I can just send it again.
Or you can just repost it, yeah.
But
I mean, it's not that long. You don't even have to copy the first part. You can just bit.ly and then 7 more rows.
I will put it in the courseware page.
Okay. So then let's continue and open the tasks. These are the tasks. To set up the database that we will use, you will click here on MariaDB. You click here, click to connect, and it should look like this on this website. So on MariaDB, click this connect button, and you will have this. And here,
just wait a bit because I need to download. So put the link here for this links. So I hope you can access the materials on the course webpage.
Can I continue? Does anyone have problems? Or is everything
Just
ready?
give us 2 minutes.
Did you share?
I'll just copy it from here. I mean, it should be.
So could I ask again? So after this MariaDB, what should we do?
Okay, so everyone ready? You open your downloads folder or your folder where you extracted the files to. You use this create database file and you just drag and drop it into here. And then it will be uploaded and you have the whole script here. So this is the script that will create the database, all the tables that we'll use for our tasks. And then make sure that you don't mark anything, because if you mark something, it will only run like the selected part. So just click here somewhere and you click on run. And this way you see here on the side, the I think it was called example table or something like this, was dropped, and we have all these tables now that we will work. So that will work with. So this is a database about a hospital where you have different tables with medicine that was administered, patients that were admitted to the hospital, the caregivers that work there, the employees that work there. So the caregivers is a subgroup of the employees, the medication that they own and how much that costs, the patients that are, what's the difference here? This is the station ID and when they were admitted, and this is the patient stuff like their name, their birth date, and their gender. The last one is the station that exists, their names, and how much beds they have, each station. So for the first task, we'll start off very easy. I hope everyone can see it.
You can open the second file as txt file and then just copy paste the solutions.
Yeah, so the other file are the solutions. So you can just open it with an editor, even though it's an SQL file. Click on open with. You can just use Notepad, WordPad. You can even use Word if you like. So it's just a text file. You click on OK. Those are the solutions. Now for the first task, we are asked to create a table that's called doctor, so that we have a table here with doctor, where we have all the doctors that work in a hospital. And it should contain the information or the attributes or the columns, the personal number, which will be the key, so it would be unique, and the subject area. So
you can also instead of the MariaDB, you can just go to the SQLite up there and just drag the file there. No,
no, I think some syntax for when we set it up here with drop if table exists only works in MariaDB. The syntax is a bit different with SQL.
Because I could do that.
Okay. I mean, we optimize it for MariaDB because the data set is.
Okay.
Yeah. Yeah. So the first task would be to create this doctor table with the two columns PNR and subject area. And to do that, let's see what the solution looks like. So just copy here under task 1A, the solution, or copy it. And then make sure that you run it here. You can right click and create a new tab, so you don't run all the script again. This task, and then let's paste it. Let's see what it looks like. So the command is create table, so very simple. Then what the table should be called. So it should be called doctor, and then in parentheses, what kind of columns you want. So you want a PNR, the personal number, as one column. It should be an integer, so this is the data type. Then you need that comma, And the next column you want is the subject area. And that should be a variable character with a maximum length of 45. So you can also set this to 99 or just 2, but it's common practice to do it to make the database more efficient and to limit this. So this is used for efficiency. And then if you don't like mark anything, or you can mark everything, but don't mark just one line, otherwise it will not work because it will only run the selected script, and you click on run, you see here on the side, the doctor pops up. So this one is new, and if you click on here, we see that it has a personal number and a subject area. Also, what I forgot to say, we here specified that the primary key is the personal number. So this is the attribute that is unique. So the doctor can have, like, the subject areas can be linked to many doctors, but every doctor will only have like one specific subject area in this case here. So now let's go to the bit more advanced tasks, or maybe not that advanced, but the second one is to insert records into the doctor table, because right now the table is just empty. We just specify table is called doctor, one column is personal number, one column is subject area. And we want to insert the data here on the right. So these pairs, these tuples. Personal number 8, so that's a doctor with personal number 8. And he is supposed to be an expert in surgery and all the other entries. So how do we do that? Let me copy the solution. And let me just remove everything from here. Or you can also open a new tab. Let me paste it. And now let's look at the syntax. So now we specify insert into. So into which table we want to put the data. Insert into doctor. Then we specify the tuples later have 2 values. So there could be 8 surgery or surgery 8. So we specify like which location of the tuple is which entry. So the personal number would be the first one, the subject area the second one. And then we specify that now the values start. And we just give like this, in Python we would say list of tuples. And this way, if we run it, you see that nothing has happened, but something has happened. We just don't get an output. So that is why for the next task, I think, we will look what this table looks right now. Exactly. So the next task is return the attributes, so the columns, personal number and subject area for all the records that are in the table doctor. So we have seen how this works in the previous slides in the theoretical part. Let me just copy the solutions, put in the next new tab. So now we want to select personal number, so the column personal number and subject area from the doctor. We can also put this in a new line, it doesn't matter. If I click on run, make sure you don't mark anything, otherwise you'll get an error message. So either mark everything or mark nothing. Let's click on run, and then we'll see that this doctor table now shows personal numbers and subject area. Since the personal number and subject area are the only columns that exist in the doctor table, we can also use like the star thing that we learned. And this will return the same. And with this website, you can even go here on the right to the tables and click on right-click doctor, click on select, and it will automatically paste like the command to see all the entries in the doctor, and you can run and you get the same result. So the next task is to modify the city and the street for a certain employee that has the personal number of 7, so that the city is Hamburg now and the street would be Big Street. So let's look at the employee table first. This is what it looks like. And for the personal number 7, we currently have Hauptstreet and City Frankfurt, but nobody likes Frankfurt, right? So we will change it to Hamburg. Let's see what the command looks like. We will use the update command. So we want to update the employees table, set the variable city to Hamburg and the street to Big Street under the condition that the personal number should be 7. So we want to replace the employee details of the employee with personal number 7. So this Peter. If we click on run and look at the table again, you'll see now that the Peter lives on Big Street in Hamburg now, not in Frankfurt anymore. Let's continue to the next task. Now we want to add a column to a table, namely to the table administered. So let's look at the table administered first. Looks like this. And now we want to add a column here that says for which sickness or illness, or what was it? Which disease this medicine is used. So we will copy again. Now we will use the alter table command. So alter is like modify in English. So we want to alter the table administered. And then we want to add a column which is called disease again. And we also specify what type of data it is. So it will be like characters again, plain English text. And we limit it to, let's say, 100 characters. If I run this, we don't get an error message, which is good. And then let's look at administered. Yeah, now we have this new column which says null because there's no data in there, and it also highlighted in green so that there's not like the text null, but it's really like null, like NumPy not available, null. Okay. So next, since we won't use that table anyway, so we added that column, but we don't really need the whole table or nothing at all. So let's see how we drop an entire table here, which this is basically done by just saying drop table and then the name of the table. If I click run, it will be gone. If I try to do it again, of course, I get an error message because it doesn't exist. In this case, you can, like in the setup, you can just type drop if table exists. If I run this, I won't get an error message because it first checks if it exists, and if it does not exist, it does not try to delete it. Okay, so this was task 1. We'll have task 2 and 3 now, and after that, we'll have tasks for you. So please pay close attention because you will have to use most of these commands that are present here. This is also why we have given you the solution, so you can look up some stuff later if you need to. So now task 2. We want to return all the records in the station table that have less than 10 beds. And the attributes to be selected, so which should be seen at the end in our output, are station ID, the name of the station, and how many beds there are. Let's copy the solution to make this fast. So we want to select, these are the columns we want to see in the end, the station ID, name, and the bed count from the station table, where the bed count is smaller than 10. We run this, we see that these stations have a bed count lower than 10. You see the station ID, the name, and the bed count. If you look at the normal station table, you'll see that we also have other stations that have bed counts equal to 10 or even higher. So our filter that we used worked for our condition. Next, we want to see which zip codes the employees have. But we don't want like a whole list with all the zip codes. We just want the unique zip codes. So no result should appear in duplicate. There should be no duplicates. Let's see how we do this. Then we can just use the select distinct. So it's not unique, it's called distinct. Select distinct zip code from the employees table. If we run this, we see that this is only 3 different zip codes. I want to leave out the distinct. You see the whole list, and you see a lot of these 111s. Okay, so this is how you do the unique thing, the right distinct. Next, what is the name and the price of medications with the lowest, no, this one, D, right? What is the lowest price for any medication? So we want to see for the medication, we have a column called price, and we want to see which is the lowest. We could just scroll through here and look for the lowest ourselves, which is kind of tedious if this were longer, and these also would contain like more decimal places. So we see like the lowest one should be 1, right? This should be our output. Let's see how we program it to get this result. Did I skip? I think I skipped 2Z. We can do this after D and E. No worries. So let's copy this D solution. So we want to select the price, so the minimum price, the minimum of the price. We specify a function here just called the minimum. These are parentheses here. I hope you can see it. Select the minimum of the price as, and then we can specify a new name of the column that should be returned. So the column would just say price. We can just call it lowest price. And from which table? From the medication table. If we run this, you see that lowest price. So this does not show price. If I were to delete this, it shows price. And you see that the lowest one, I've deleted the parentheses. It will just min price. It will show the function that we used. Yeah. So now let's do E and then C and then F. Okay, so E is what is the name and the price of the medication with the lowest price. So now we want to see which kind of medication actually does have this lowest price. But we want to see all entries, not just like one that has the price of one, but we want to see all medications that have this price equal to 1. So we can just run this script here, get the 1, and later filter medicines that cost 1, but that would be like kind of dumb. We can also specify it. And let's see, look at the solution. So we want to see in the end the name and the price from the table medication, and our condition is that the price should be equal, and this is exactly the solution to our previous task. So you can like have these like on the first level, look how much is the price, and then use also like this statement as a condition for even for another command that you run. So you just write where price equals, and this is exactly like the solution to the previous task without the renaming of the column. Right, so if I run this, I see that bipanthen and these coagulants all cost 1. Next, let's do the C now that I skipped. So I did A, B, D, E, and now let's do the C and then the F, and then Gary will take over. So for C, we want to return all caregivers who live in London. So this should be fairly easy now. Let's copy this. Our problem is that the caregiver table, let's look at it, only has the personal number. So we only know which personal number is associated with being a caregiver. But to see where they actually live, we need the employees table and link this personal number to like the city, I think was asked. So how do you do this? You have to link them. You have to join them somehow to get this data. This is done by, you want to specify which tables you need. You need the caregiver and the employees table. You can give them a new name for the code, so you don't always have to write caregiver.personal number. You can just write c.personal number. So I specify that caregiver should be named C for this operation, employee should be E. These are the 2 tables that I need. The employees gives me the city, the caregiver gives me the personal IDs of persons that are actually caregivers. And we want to select the personal number from, like, let's say caregiver, so it doesn't matter if I write C or E here, they both contain the personal number. And we want to see the name, which is given in the employees table. So not the, yeah, so we want to see the name and the personal number. And our condition is to link them, the tables. We wanted the personal number of caregivers equal to employees. So we make an inner join in theory, so that you only have like the whole table of those that are caregivers, and you have like one table which are all the caregivers, but also contain all this data which is in the employees table. So like the date, birth, street, city, and zip code and thing. And you want to specify a second condition, and you actually have to write and. So you can't write like a next line with where again. You have to write and. This is important. It may be important for a task later. And we want to have the city equal to London, and where is the city located in employees table? The e.city. So if I leave out the C and this E here, you would always have to write caregiver.personal number, employee.name, caregiver.personal number, employee.personal name. So it's much more easier to just give them like a new name for this operation. If I run this, you see that person number 4 and 6 are both caregivers and live in London. And their names are, like this one is just called M, but this one is called Ada Lovelace. So the next one is, are there any caregivers who are also doctors? So you might see that this also requires us to make a join, because let's look at caregivers again. You only have the personal numbers, and you want to see if they are doctors, so if any of the personal numbers are matching. Yeah. You want to output their personal number and their name. So let's look at the solution. This should be F. So what do we need? We need the, just task again. Yeah, okay, this is the right solution. So what do we need? We need the personal number that we want to show in the end and the name. We want to get them from caregiver, which we will call C again, employees, which we call E again. And we need the following conditions. So we need to link the caregiver and the employees table to get the name from the employees table in the end. But we don't want to see like all caregivers, but only those caregivers who are also doctors. So we need a second condition, which we'll write with AND again, so no second where. And then we can say that this C personal name, so this caregiver personal number, should also be in this query result, so in the list of personal numbers from the doctors. If I run this, you'll see that there's only one. It's our Ada Lovelace with personal number 4. So this would be all for task 1 and 2. Garrick will now do task 3, which will be even more advanced. And afterwards we'll give you your task with also 3 different kinds of difficulties. So you should at least be able to do one of them.
Okay, so thank you. I'll try to do it a bit faster. The other group also have time to do presentations, sorry. So, task 3. For medicines whose names start with IB, I'll put their medicine name, producer, and price. Upper and lowest case should be taken into account. So, we copy our solution. So, we need to select name, producer, and price from medication as given in task. Name, producer, and price. And from medication, and now we have our condition where binary name like IB. First, I'll explain what binary means. Binary is a function, and it converts all objects or characters into bit objects and compares it like bit objects. Because, for example, I and small I and capital I have different IDs. That's why we can use binary to find all medication that start only with capital E and then goes B. This percent means that we can have afterwards as many characters as we want. So if we run this.
So basically, this binary thing. So without the binary, it won't be case sensitive.
Mm-hmm. Okay. So and we have ibuprofen from Bayer and with price this. If we delete this, they will have also the normal output because we wrote everything correctly. But if we now write with small I, then they
will find it because we don't have binary yet. So if you
yes,
binary back,
yeah.
you won't find it anymore.
So now we have nothing. Next task 3B. For each producer of medicines, give the number of entries as well as the average price of this. Sort the result in descending order by the amount, and if the amount is the same, in ascending order by the average price. So first to the first part, we should we should select producer, amount of medicines, and average price. I will come to this count and average price a bit later. So amount as amount, price is average price from medication. And we already learned in Python, in pandas, the function group by, and we can group our entries by producer. So the table medication has following columns: name, producer, in stock, and price. And we see that producer can be each producer can make multiple medications, but we want to know how many types of medication does every producer make, and the average price of each medications. That's why we select producer, amount, and price average. Then we group by producer. And what does count make? Count counts the number of rows. If we don't group by the rows, it will count each row. But if we group by producer, it will group by producer and then count how many entries gives in each producer. And the same with average price. If we remove group by, it will return the average price of all medicines here. But if we group by producer, it will take all medications from one producer and calculate the average price. And we have also the other function, order by. It's like ordering, and we write on which criterion is amount in descending order, and if it's equal, then average price in ascending order. Now we'll see the output. So as we see, we saw some multiple times Hexal, and it has 18. It produces 18 medicines, and the average price is 11. And this looks like for every producer of medicine. If we remove this group by, we will have only one row. I hope. Yes. It's total amount of 46 medications, and the average price of all is 56. We have here producer X Hexal because the first output here is Hexal. If there was a Rita, then we would have here also first Rita. So this doesn't mean anything. So now the next task, it's actually the same, but with one extension. Only show this average. Only show this with average price larger than 50. So we want everything that we done, like so. This was our previous output, and we would only return the producers and the amount and average price only for those producers whose average price of all medicines is larger than 50 or less. I forgot. And we can do this with having average with having. This is like where clause, but having can be used only with grouped entries, and it can be also used in where clause. If we write select producer average from medication where average price greater than 50, then it will first do this, select from the whole table. And for example, if we have for Hexal, for example, one is for funnel here 3. For funnel, we have first medication with 40. Okay. 40, then second 90, and the next is 100. So it will only count if we write it here where price is greater than 50. It will only count this one and then give us as amount 2 and not 3. But if we write it here after group by, it will also count everything. And we also don't allow to use any aggregate functions like min, max, count, average, and sum in where clause. This is not allowed. We will have this syntax error. So yeah, now we have only the outputs with which average price is larger than 50. So next task. If you have any questions, don't hesitate to ask. So return the subject areas for which more than one doctor is responsible, whereby these doctors must have been born in 1917 or later. Also give the exact count of how many doctors are responsible for the subject areas. So we select subject area. We don't write here D subject area because subject area is unique count for doctor table. And we also count this. Now we make here inner join. D personal number is equal employees personal number because we employees the table contains information about caregivers and doctors, and we want only doctors. And also the date birth of each employee must be after 1970. So we also group this by subject area, as I already explained in previous task, with having count larger one. It means that we want to select only these subject areas for whose more than one doctor is responsible.
So here, if you drop the count as the amount, if you drop that, you get an error.
No.
Well, you need that.
Because we should select it. How many doctors are responsible for this subject area? We want just to show. So now we have subject area general medicine amount 2. 2 doctors are responsible whose birthday is after 1970. If you remove this, we have only subject area.
Or like instead of the okay.
So I can now open subject area. Doctor show table. So we have here 6 doctors, and as we see here, maybe I think the doctor with personal number 4 was born after 1917, but we don't select the subject area because only one doctor is responsible for neurology. But for surgery and general medicine, 2 doctors are responsible who were born after 1917.
So basically, you need it not for the condition, you need it for the showing.
Yes, I need it for showing. Yes. If I remove this having count, then okay, because the other doctors were born before 1917. But if I make it larger than 2, then I will have nothing. It's because maximum is 2. So, and the last task. Select employee name, subject area, and zip code for employees whose zip code begins with 7. And if the employee is a doctor, also the subject area. Here we will use left join. As we know from pandas, we will have the whole table of employees whose zip code begins with 1. And we also have entries and we also have as return the subject area if the employee is a doctor. So we need the whole employees, and if it's employee doctor, we will return also the subject area. If not, it will return null. So we left join. On the left is employee, and on the right is doctor. Employee will larger than doctor, and we will select name, subject area, and zip code without E or D, because these tables are unique. And the syntax is so: we select select the tables, then from employees, and employees left join doctor on which condition? E personal number equals D personal number. And where substring zip code, substring is a function like slicing for Python. The first argument is an object which we want to slice. The second one, we say from which
index location.
Index location we want to start. Here is not like in Python with the first entry is null, but its first entry is first, and the third parameter tells we want to tell it how many we want to select. So we want also only have the first output as the first character. If we write here 2, then we'll have the 2 numbers starting with the first. So as we see, we have now here names and subject areas. We only have 2 guys here who are doctors and whose zip codes start with 1. And I have here also order by condition to make it look nicer a bit, because we only, for example, only first not null values and then null values. So we have here our 5 doctors without 1, and the other guys are employee, the caregivers, but their zip code start with 1, and that's why we return it. If you make only join, then we don't have any. I think we don't have any caregivers. Yes, no caregivers. But with left, we will have them. So I hope this was.
So the join itself is an inner join, right?
Yeah. If you only write join, it's the same as where you have when you write where personal number equals personal number.
Theoretically, I could remove this and this and write where E-piner equals D-piner. There are also, you can see in cheat sheet, right join, cross join, and outer join. Outer, but the other one are not relevant. And also one hint: if we make here from, I forgot this to explain. If we make here, for example, from employees E and doctor, we will have the. It means like I don't know, dot product or Cartesian product.
But I think we need to wrap it up.
Yes, this is Cartesian product. So.
But can you just introduce the homework so people can just do it really?
These are just add the new column height to employees and insert to piner 1 the value 170. The second one is which producers make the medicines that are more than twice as expensive at the average price of these medicines. And the third one is task we left join. And
we can publish the slides and the solutions online. So
yes,
I will put it on the homepage, and and then the second group is presenting the SQLAlchemy, which is a platform that you can basically connect SQL with Python. You also need to use your subscriber.
So hello everyone, welcome to our presentation. My name is Tunhan, and today I and my colleagues Berengiz and Javed will present a topic called SQLAlchemy. But before we start talking about SQLAlchemy itself, I would like to give brief information about the data management structure, and to talk a little bit about the terms that you see on the slides, since some of us might find them a little confusing to differentiate. So let's get started. A database is an organized collection of structured information or data, typically stored electronically in a computer system. And the database is controlled by a database management system. Database management system, also called database software, is used to create, edit, and maintain database files and records, enabling easier file and record creation, data entry, data editing, updating, and security. It also handles data storage, backup, reporting, and also multi-access control. And together, the data and database management system, also the applications associated with them, are called database system, or often shortened to just database. And there are different types of databases, as our group mates already mentioned. And one of them is relational database. And today we will mainly talk about relational database. And the items in relational databases are structured, are organized as a set of tables, typical tables with rows and columns. And finally, many databases use SQL to query and write and access the data. SQL is a programming language used by almost all relational databases to query, define data, and also give access control. So now let's move on to SQLAlchemy itself. SQLAlchemy is basically a Python library for working with databases and Python. It has many functionalities which can be used individually or combined together. For example, SQLAlchemy enables us to execute raw SQL statements in Python program itself, like rather than using separate IDE or shell. And by using SQLAlchemy, we can just write Python code to for example, to create, update, write, or delete instead of using SQL codes, which actually speeds up the development time, especially for developers who are not fluent in SQL. And it also makes database management very error-prone. So here you see the two components of the SQLAlchemy. Now I will talk a little bit about the technical side of SQLAlchemy. Here we have a DB API, which stands for Database API. And they're used to basically to define how Python models, which integrate with databases, should expose their interfaces. So to put it in a simple way, they just defines how the common functions such as create and close, which are used to connect and the close connection to the database should behave. For example, one of the most popular DB APIs for the database management system called Postgres, which is also one of the most famous database management systems in the world, is called SQLAlchemy, and it means that if you want to work with Postgres, a database management system, then you should install SQLAlchemy, and you can do it using pip install. And by the way, you can also download SQLAlchemy library using pip install. And then to create a connection to the database, next we have to create an engine. Engine basically manages pools and the dialects, which SQLAlchemy uses to connect to the database. And to create an engine, we have to first import the create engine function from SQLAlchemy library. Now, and then we have to issue a call to it. And how we do it, we basically give the first type of the database management system, in this case Postgres, and then we give the username and password, and then URL, and also the name of the database. And then we have SQL expression language here. SQL expression language is a toolkit on its own. It is separate from ORM, and it's used to provide a system of creating SQL expressions, which can then be executed against a target database and giving a result set. And as we said, SQLAlchemy is an object relational mapper, and it's just object relational mapper converts Python classes into and from tables in relational databases, and it also translates function calls to SQL statements. So now I just want to show some sample codes for creating our database and inserting some data inside it. And we can do it in 3 different ways. First, we can use raw SQL, and then SQL expression language, and then ORM itself. So let's start with raw SQL. As I said, first we have to create an engine, and we give a call to it, and then we can just execute the raw SQL statements inside execute method. And as we can see, this code is actually getting a little messy because the strings, first of all, are a little longer, and also we would run into an issue, for example, if we needed to use like a double or single quotation in any field, since we have used both of them in this case, like a single quotation for Python strings and a double quotations for SQL strings. And next, I want to show you how we can implement create operation using SQL expression language. Again, like to talk about the same concepts as before, but this time, from the perspective of Python, we have to have other imports such as table, column, string, and metadata. And this time we create table using the Python class. This is the biggest change from the previous code. And then we just call create on it to create the table itself in database. But as we can see, this code is actually like a bit longer than the previous one, and also it's a bit difficult to read maybe, so it doesn't add much over the raw SQL query. But the thing is that, as we can see, we're now moving towards interacting with our databases in more Pythonic ways, since we're using the Python class. And now, finally, I want to show the same operation using SQL ORM. So in SQL ORM, we just reach to the highest level of abstraction, and here we just can do everything just using Python objects. And because in previous code, as you saw, we just had this insert statement, which was kind of similar to SQL. So in this case, we're completely away from, so to say, SQL, and we're just using Python objects to create table and insert data inside it. And yeah, basically, just the sum of all these codes, we can just say that SQL ORM can provide some benefits over SQL query itself in 3 following ways. First of all, as we saw, SQL using the SQL string as a Python code can get really messy. So using SQLAlchemy, we can achieve cleaner codes. And it's also SQLAlchemy ORM can help us to mitigate to mitigate problems associated with, like, for example, there is an SQL injection, which is one of the most famous hacking methods to get data from SQL, from database. And finally, as we said, we can use SQLAlchemy ORM to have simpler codes And in this case, we don't need to think about our database logic on a table, row, and column level. Now we can do everything on the Python attributes, objects, and instances. Yeah, that's all from my side. Now my colleagues will show the practical side of the codes.
Okay, sorry, it took a little bit long. So as Pinhan described, there are two parts actually of the SQLAlchemy. I'm first going to describe the SQLAlchemy core, and then my colleague Javid is going to continue with ORM. And yeah, let's get started basically. I hope you all download the DigitPeter notebook we shared in Piazza. And as we said, like there is also one browser called SQLite that we shared the link. It would be more preferable if you can download that one as well. But I think we can do without that as well. So yeah, I'm gonna get started if no one has problems with downloading. So first of all, we're gonna start with installing the library called SQLAlchemy and import it. At the same time, I'm going to import the pandas library because it's going to be useful in our case. So I'm going to install. In addition to that, I'm going to import the create engine text and metadata from SQLAlchemy code. I'm going to do the version check because it's really important to have the latest version. It sometimes makes problems. In our case, it's 1.4. So yeah, after doing all of the things, we're going to continue with the turning the database engine. So it will help us to interact with the database. First, we need to for that we first need to establish a connection. So actually, the engine defines the connection of our language, in our case, the SQL, and it will help us to use it in Python. So for that, I'm running this code, create engine, and the database DB is also shared in the Piazza. I hope you managed to download it. I'm gonna also read this database so that we'll use it like in our code.
Just important that your this SQL database file should be in the same folder as the other with the Jupyter. Yes.
Yeah, exactly. If not, you can just use the path. It's going to work as well. And then after defining the engine, I'm going to use the connection. It will help us to make a connection between this. And after doing all of these things, now we're ready actually to read the data. And here to read the data, I will first use the normal role level reading the data, which in my case, I will use connect execute, and I will write the simple SQL code inside of it, which is the select star from customers. Customers is our database table, sorry. It's the table in the database, and I want to get like the all columns in the customers table. For that, I write this code and write the for, and if we run it, we'll see that we get the result in the case as the text. The other version we can do, it will be more preferable in the Python, I guess, like you can read the data with the help of the pandas, where we have the read SQL code, and at the same time we should write our engine to get the data in the form of the pandas. And Here you can see we have the columns like customer ID, first name, last name, and whatever we have in our customers actually table. I go down. This is the another version. Again, like with the pandas, we can read SQL, and I wrote like specific names of the columns that I want to get, but in a form of the SQL, which is like the customers is our table. I write customers dot first name. First name is the name of the column, and the other columns such as customers last name, city, customers company. At the same time, I write the invoices total. Invoices is the another table which has the column total. And for that, I write, I get this values from the tables named customers and invoices, where customers customer ID is equal to invoices customer ID. So customer ID is existent in both of these tables, so we can match these two and get the basically like the combined result as a table in this case. So we can basically do it directly in the Python instead of going to SQL, so to speak.
So basically, you can now do everything that the previous group was showing you with all the select things that you could create. You can just directly go to here and import it as a Panda data frame. So you don't need any other interface to work with the SQL.
Yeah, exactly. This is again the same thing, just in another form, if any of you just wants to get this. So yeah, I'm gonna go to the describing the database. So for that, I will start from scratch. I just wrote the engine, did connection, and also I created the metadata, which shows the connection between the tables and the Pythonic representation of it, which we have here in the Python. So like it bounds these two together in the metadata. And in addition to that, like these are all the tables that we have in our database, customers, invoices, albums, and so on and so forth. I will directly create them in the Python with the help of our DB is our SQLAlchemy, as we named it, with our table code. So that we have in the SQLAlchemy, I write that it is table, which we get from the customers. I show the metadata and engine and so on and so forth. So we can basically import this all like to the Python. For example, as we already did it, like we can print the column names of the tables that we imported. So like for that we write print customers columns keys. So which gives us the names of the columns that we have in the customers. In this case, it's the genres and invoices table. So we can basically directly get the print of the names of the columns. The other thing we can do is basically we can print the full table metadata. In our case, for example, if I do it for customers, we can see that there's table customers. At the same time, we can see that it is an integer, and we can see that this is the primary key. So primary key in our case is like for the for each table, we have the ID, which shows that, like, for example, in the customers table, we have the customer ID, which is the unique value for each rows. And it can be helpful for us to make joins in the future with the other tables. For that, I also do the same for the invoices. And in this case, we see that like in the invoices table, invoice ID is the primary key, but there is also the foreign key, which I don't see right now. I hope you see it. Yeah, foreign key, which is the customer ID. So with the help of the foreign key in the invoices table, which is customer ID, we can actually merge they have the relationship between the customers and invoices. So customers ID existent is two tables. So then I'll just move to the querying. In the querying, so basically write the query. We write the select function that was explained already, like by the previous team. I choose everything from the customers. And for that, I also, in the SQLAlchemy code, I just have to write the connection execute to get the results. And we can write it in this form as we did before. And we can make a print of the query, which gives us the names of the columns. But to get the direct results, we basically need to create the result proxy, which is the object that's returned by the execute method, and it can be used in a variety of ways to get the data returned. And the other thing that we need to create is the result set, which is the actual data that we asked to fetch the method. So we do that, and by writing the result set, we basically see I only want to get the first 5 rows, and you can basically see this data with the help of the query, so to say. Then I will again like to convert it to the data frame with the help of the pandas, and here we see again the columns. But if you want to access the columns without pandas, you can basically write the name of the, for example, in our case, it's the employees table. You write columns and employee ID. It will return you the names of the columns and the name of the column, and it's actually the so to speak description. Yeah. And so yeah. So the other thing we will need to see to make the merge between the tables, we need to define the primary and foreign keys. To get the actually primary and foreign key, you need to write this code for primary key and employees primary key, print primary key, and the same for foreign key. So you can basically see what is the primary and the foreign key for each table. And if you move to the expressions in SQL, I'm going to show you all of them. Not all, the majority, but the details you can see in this link. And for example, we have the where clause that was explained again. This is the version that has been shown by the previous team. And we're going to do it in Python, so in a bit different way, SQLAlchemy way. So I write the query, I select the customers, all values from the customers table, and I write the where clause. So I write the where, the country column in the customers is equal to Brazil. To get the results, I again write use the execute function, do fetch all. And I also want to get this result in the form of the data frame form. So after writing all of these codes, we basically get the results of all countries that is equal to Brazil. You can see this thing. The other thing we can do, or you can do it directly in pandas in a simple way, just by writing the SQL code that has been written like in a normal form, you again gonna get the same thing. And the other thing we can do is the in clause, like with the help of the in, we can actually use the several countries, so to speak, in our case. For example, so we write the query, I specify in this case like to the specific columns. For example, I want to get the first name in the customers column, I want to get the last name, where customer columns country is equal to Brazil or Germany. And you basically get these names in these countries. So, and this is the simple version for the pandas. The other thing we can do is and or not clause. Again, like in this case, we write it. I select all data from customers table where customers city is equal to Sao Paulo and first name is equal to Eduardo. So there is only one case for that. Or I can change it, for example, to or. It should work. Oops. Yeah, because I didn't run this all, but I didn't run from the start. So, but in normal case, it's gonna work. It's gonna return the either the all countries of Sao Paulo or the Eduardo. So it's gonna be more values. So yeah, I didn't run this all. The other thing we can do is the order by. So with the help of the order by, we can specifically get the order of the results that we're getting. In our case, I choose the descending order for the country column, so that it starts like from the countries that start from the last alphabetical, yeah. And I also write this get at the end, like I want to see only the first 3 results, not to get all of them. So I see that the countries start with the United Kingdom, as we did. And the other thing we can do is the group by, and we can use sum and average or other things like minimum, maximum. So you can basically change this sum to the AVG, or you can write minimum. You're gonna get like different results. And in this case, so we basically write the sum of the all, so to say, total amount that is spent on the that is written in the invoices by the specific customer ID. So like how much money in total did each customer spend, so to speak. Yeah, and here we get that the total of the first 3 customers. Then we move to the distinct, which gives us the distinct results of the cities here. And here we have the join. Finally, we move to the join. For that, I started like show everything that I did already. I have a look at the primary keys and the foreign keys where I see like the for the customers and the invoices, like the customer ID is the match. So to join these 2, I basically write the join function of the invoices with customers, as we can see from here, where the customer ID is equal in both of these cases, which is going to merge this, and we can see that like the customer, we have 2 customer IDs here, like one is here of the other data, and this is of the first data. So these 2 has been merged. The other thing we can do is the automatic join without even mentioning which columns should be equal in this 2. It's gonna give you the same results. Yeah. So after all, we can actually also insert the data to the existing database, and yeah, we can okay. So we can basically insert the data to existing database. I'm gonna choose the albums data, and I'm going to add the values. Whatever. I'm going to add the values to albums data. So okay, I'm going to show it. So I'm going to add it to albums data. So after this, writing this code, so you basically in the data that we had, like that we downloaded, you'll see that it adds 1 additional row at the end with these values for the album ID, title, and artist ID.
So you need to change the album ID because it has a unique key and you're duplicating.
No, it's about the database name in the folder.
Yeah.
So when you create the second time, then you should.
Yeah, it's just too late to do it again. So also at the same time, you can create and insert the data with the help of the table. So I'm going to create a new table with the column called ID, name, salary, active. And so like we specify ID as integer, name as a string, salary as float, and the active as Boolean, where we can see that the default is true. And then we basically add these values by inserting, so that I'm going to write that ID is equal to 1. I can actually do that, but I don't think we have time for that. So I created basically the database called test1 with all of these values. I basically added these values, like for ID1, name is Naveen and whatever. For the ID2, the name is Ram, salary is 80,000 and active is false. And after showing this all from here, we'll see that we got this database, and we can actually open it in the same file. You'll see that there is a test1 file created, which I can show you in the SQLite that we downloaded, but I don't think we have time for it. And
just go through the exercise a bit.
We have the exercise, which shows that which genre of the song has the highest milliseconds on average. So for which we have to merge the general table with track table. Do you want me to show that first?
It's there, right? So
no,
it's
not that one. I can show you, because I don't think we have time for that.
Exactly, that's right.
I have many things.
Okay, exactly.
So yeah, I'm gonna just show the answers very, very quickly. So I again upload this all things here. I look at the basically primary keys and the foreign keys of these two tables, and where I can see that basically the genre ID is existent in both of this basically tables that we have. And for that, I first write the query. I write that I select everything from tracks and genres. And as a second query, I already choose the query that I created. So we have everything that in this two. So I select basically I try to join the genre with tracks with the help of the genre ID. And after doing this, I basically get the average of the milliseconds, which I also name as the average MLS. You can see the result here. Which is grouped by basically the column name 1, which is the genre name that we merged here. Because after merging, the name is written, these names there are two names in these tables, and the second one is called as name 1. So here you can see the result, and we can see that metal has the highest average MLS. I'm gonna pass the stage.
Okay, so I hope you understand that we have a little bit of time issue, but I think.
Okay, I'll be super fast.
Okay, great.
Okay, I'm going to explain about object relational mapper in SQLAlchemy. What's the main difference? It's created after core, it's based on core. Why it's important? Because it creates class as a Python object, which helps us in high automation process, because it's easy to use Python objects. If you have one runtime query to ask something from database, it's better to use core. But if you want to create an application, web application, ORM is really helpful. I'm not gonna run the code, but I'll explain one by one. The installation and imports are same. There are two different things we have here. First of all, session maker. You remember that in the core part, it was connection.execute. Here we have sessions, which are somehow the gates that store the data for temporarily, and it's called query object. I will show you in details. Also, I imported the randoms to just iterate numbers for our database. Again, we are creating engine, everything is same, and we are declaring our base as declarative base. How we are going to create table with ORM? As I said, it's Python class, so we are creating class transactions on base, and we should add a table name. It's mandatory, it should be there, because we are going to use transactions. We have different columns. Again, we are defining the primary key integer, and we have also date, item ID, price. Okay, you can see here we have the raw SQL version of the code, how it's working in the background. When I run the code, it gives us, it gives a new SQL file in our folder. You can use the browser to see the data here. Now I'm going to do operations. Firstly, I need session. To create session, I bind it to engine. It means that whenever I run the code, session connects to the engine and it keeps the query there. For example, if we want to add data, iterate the numbers, we can do it with loop, which is from 10 to 20 as an ID. It should be unique. We are adding price and also the date. Our code is session add here. The one important note is we should commit everything after writing the code. Session.commit method is for that. I added the image to see what's created. Also, you can track from the browser. Okay, just quickly run because okay, for example, this is our new table created here. And we generated random numbers. If you want to see the data, it works same as core, nothing is different. It will give us additional functionality in the future. The syntax is a bit different. For example, you can see that here we have a query object, I named it extracted, and with loop I am generating the all columns one by one. Here I can add single transaction, just session.add, then I should commit the session. You see, it's added in our browser too. We can add multiple transactions. I'm gonna run. Just we need to give the list of transactions and use the add all command. You see, it's also increasing here. Here we have sorting. It's order by, same as before, same as core. What's different? We have filtering instead of select where from thing. For filtering, we use the filter function after writing our query. For example, here I'm just querying for transaction table and filtering price over 40. Other operations are same equal, exclamation mark equal. And you can see here it's writes select from transactions where greater than. And you can also use the count and other functions. Not all of them same as, for example, you cannot use sum, but there are a list of functions that it's also possible to use with the query object. Okay, updating and deleting. Updating is when you select the query, you can see that session query transactions is filtering. With transaction ID, it gives me one transaction, and I can change basically extracted.price equal to 100. It will change my price to 100 for my unique transaction ID. Delete is just .delete. When I extract, as I said, session temporarily save the query. So when you use extracted delete, it considers that we are choosing that line and we are deleting only specific item, which is transaction ID is equal to 10. In our case, okay, you can see we post transaction ID. Okay, the second part will be auto mapping. We said that we can create tables with class, but like the first question came to my mind. Okay, if we have existing database, how we are gonna convert all tables to classes? So we have the different base for that. Auto map base. You can see that here we make our base equal to auto map base. The engine is same, but the only thing we should do is writing all table names as class names. Like it will automatically connect it to the database, will take the tables, and it will also create the relationship. It's not, I wouldn't say it works 100% every time, but it works generally. On it. Okay, the same as we can extract the data from the existing database. We are using the same database as in core, it's database.db. We can inspect relationships in different way than core. There is inspect that we can import, and when we write relations is equal to inspect tracks, it gives us the list of relationship of track table to the other tables. Okay, join. It's simple. Dot join to it's in default it's inner join, but you can write outer join. Just simply to give you outer join. You can add filtering, sorting, and selecting first item or all items, all of them at the same time. I would like to show you what's extracted here. When I write query, gives me extracted. You can see that extracted is just a pass. Like it's query object, it doesn't give us much, but when we print it, it gives us SQL code, what's connected to what, whatever extracted, it gives details. Okay, it was quick. At the end, I had exercise which is solved most in USA. Like, yeah.
Yeah, great.